In this demo, we'll show the basics of the storage market. The commands and interfaces shown here will change significantly as we implement the protocol and flesh out features. First, let's start a local testnet with a few nodes. We'll disable client market actions so that we can see just our activity. The miners in the network are mining blocks and adding storage market asks. We can see the network in the visualization, including the storage market starting to fill with asks. In the top terminal, we'll start sending commands to one of the miners through its API. Let's add an ask to the market, which tells the market that this miner is willing to store data at a particular price. Asks also include a duration of time, but this is not ready to demo yet. Let's set a price lower than everybody else in the market. This way, we'll get the business. Our ask will show once the next block is mined. There it is. Now, let's make a client store some files. Once the bid is in the chain, it locks funds from the client. Now let's hire the miner. To propose a deal, we need the IDs of the asks and bids. We can inspect the live asks and bids with the order book command. Here are the asks, and here's a single bid in the market. Of course, there are no deals yet. We import the file we want to store. This calls IPFS importing under the hood, so it will chunk files automatically. For those of you familiar with IPLD, both the files in Filecoin and the entire blockchain are structured as IPLD. The propose deal command does several things. It finds the miner who created the ask in question. It sets up a direct connection to them. And it sends a deal proposal from the client to the miner, which references the ask, the bid, and the data to store. The miner receives the deal and considers it. The miner can reject the deal if the asks and bids don't match, if the miner's asking price has changed, or if the miner simply wants to refuse this client or this deal in particular. It's an open market, and the client should go find some other miner. If the miner accepts the deal, it lets the client know, and the client schedules the transfer of the relevant data. If the data is small and can be easily sent over the internet, think gigabytes scale or less, the client just sends the data over the protocol. If the data is too big to send over the internet easily, think many terabytes, petabytes, or higher, the miner and client can arrange a separate data transport over much higher bandwidth links, such as package switching, shipping containers, or station wagons loaded with tapes speeding down highways. Note that the transfer of data is completely verifiable, and the miner will only accept data that matches the deal. Once the miner has received all the data, it signs the deal and returns it to the client. The miner or the client can post the deal to the blockchain to finalize the transaction. By default, the miner does it, but the client is able to do it as well. This covers an important protocol edge case. Once the deal is on the blockchain, the miner is responsible for storing the data and will be tested on it periodically. This sounds like a lot, but in the general good behavior case, it happens very quickly. In this demo, the miner will accept the deal automatically, and the data transfers immediately. Watch the visualization. When I press enter, the deal will trigger and the file transfer will happen. All right, at this point, the miner and client have struck a deal which is logged in the storage market order book. We can see it both in the visualization and in the command line. Finally, let's see another client retrieving the file. Let's grab a node we haven't used yet. Let's find the data referenced in the deal. And let's download the file using the client cat command. This finds and retrieves the file from the storage miner. We can diff the new file against the original to show they have the exact same contents. Now, let's check out what we stored and downloaded. Some final notes. The retrieval market is not in this demo, as it is still a work in progress, but conceptually, it will function similarly to the storage market. In the future, market orders, asks, bids, and deals don't have to happen through the blockchain. We have working designs for running markets entirely off-chain using payment channels.